G'day, Mark Pesce here, back again for part 2 of spatial computing, a history. So in part 1, we talked about the history of spatial computing, which goes back really almost 70 years to the F-86A jet fighter, and how it had a control system that was starting to overwhelm human cognition. And so work began primarily in the defense sector to be able to work on a new generation of interfaces that could actually make all of that information apprehensible and operable by a single human being. And we get to the work of Ivan Sutherland. Ivan Sutherland is one of the great stars of computing, who started off with what we call Sketchpad, which was the first interactive computer program, and then went on to prototype what he called the ultimate display, which was the very first head-mounted display system, which kicked off what we think of as modern, augmented, and virtual reality systems. All right, so we actually roll through all of that. We roll through the first stage of virtual reality, kicked off by NASA and then picked up in some ways by industry, but it was very expensive. It was very hard to use. It was cumbersome. It required about $1 million of computer, basically a supercomputer, to be able to generate the images. So it was out of range for most people. But we had an enormous period of tech development from around 1995 to around 2015. So during that 20-year period, systems got about 1,000 times cheaper and about 10,000 times faster. And we had two significant developments during that period. One of them was that increase in computing, and the second was the smartphone. Smartphone integrated a whole bunch of these computing devices into a single platform, which was capable of being connected, was capable of knowing where it was, how it was looking, and also had a high-resolution display. So basically all of the elements that you might need for a virtual reality system. And then we started to see in very quick succession a range of devices that rearranged what we think of as smartphone components into various systems. The first of those was Google's Cardboard, which basically allowed you to slap some cheap lenses and a cardboard case over a smartphone and turn it into a low resolution but still completely adequate virtual reality device. And all of a sudden the number of virtual reality devices in the world went from maybe a few thousand to a few billion. And now we start to see what happens when designers actually start to design specific systems using these components. And the first of these is the Oculus Rift. And Oculus was founded by Palmer Luckey, entrepreneur, still very big, billionaire now. This was his first device. He did this when he was 18 years old. He basically used a whole bunch of available off-the-shelf components to integrate into a system, which he then put up on Kickstarter. And it became, I think at that point, the most heavily funded Kickstarter of all time because there was an enormous groundswell of interest for it. And it came to market in 2012, 2013, the DK1. It was relatively low resolution, but it used tracking systems, which had gotten a lot better in those years. If you remember, the original sort of Damocles system had this mechanical tracker, and then we started to go to magnetic trackers in the 1980s and 1990s, and now you have fully optical trackers, which is what the Oculus Rift does. So basically uses cameras to track the locations of things. And this system became sort of the standard platform for the modern virtual reality systems. We started to see several others also come out. So within 2 years, HTC, which primarily makes smartphones, worked with Valve, who makes Steam, which is a big games platform, to produce the HTC Vive. So this is a high-quality, high-end virtual reality system. But when I say high-end, it was possible to go all in on a high-end virtual reality system with Vive plus the PC plus the graphics card needed to run it for about $4,000. So if you figure that an equivalent system just a few years before would have been $400,000, you can understand what happened. So this becomes now the consumer era of VR, and that was really sealed when Sony came out with the PlayStation VR, which is a plug-in for the PS4, PS4 Pro. It has a head-mounted display and a camera, and you can tell by the lights that are on the head-mounted display that the camera is actually tracking those lights in order to understand the position and orientation of the head and the controller, which you're holding in your hand. And so you have this range now of consumer high quality, like far better quality than you would have seen in any system at any price just 10 years before. High quality VR systems coming to market. Meta, Facebook, buys Oculus for, I think, $3 billion, which is how Palmer Luckey first became a billionaire, in 2016, and then produces the Meta Quest line of headsets. These are now the best-selling lines, and these are the ones that you are, in fact, using in class today, the Meta Quest. And so Meta, Facebook at the time, was going all in on virtual reality and on what they called the metaverse, which is connected virtual realities. And we haven't really stopped to talk about that. That's a whole topic on itself. The history of the metaverse goes back about 30 years, and really for as long as we've had virtual worlds, we wanted to be able to get more than one person in the virtual world at a time, and that was very hard to do. Meta decided this was a problem they could solve because they're a social networking company, and they actually changed the name of the company, famously from Facebook to Meta in 2022, to put the seal on that change. They're now the biggest maker of headsets in the world. Okay, so let's talk about what people did with these systems. There's three key programs that were introduced at the beginning of this new wave of headsets, which shows you what was possible with good virtual reality systems. And the first outstanding example is Tilt Brush, which is a program that was created by Google. You can kind of think of it as Photoshop, but in 3 dimensions, really 4 dimensions, because you're working in time. And so that you're working inside of a completely immersive environment with a paintbrush. The controller becomes a paintbrush with a whole bunch of different options about how you paint and what you paint and where you're painting it and what that painting does once it's created. And you can save it and bring in other paintings and add to them and so forth. So it's something that's like a painting tool, something that's like a sculptural tool. It's really kind of hard to define, but the one thing that I know from having introduced a lot of people to VR using Tilt Brush is it's a great introduction, because what it does is it centers you in your body, and it's finger painting. And everyone loves finger painting. So it's something that people can learn very quickly and feel good about very quickly. And this became, in a sense, the archetype for the new kinds of work that people were doing in virtual reality. Now, Google had another great, outstanding piece of program called Google Earth VR. You've probably all used Google Earth, which can basically present a model of the Earth and bring you down almost to street level pretty much anywhere on Earth. Well, Google Earth does that in VR with Google Earth VR, and it immerses you in that synthetic environment. And this is actually really difficult to do because the world as a database is enormous. And so Google had to work out how to feed you just the right bits of data at the right time. And the other thing they had to work out was how to keep you from becoming motion sick as you're moving through this world at speed. And one of the things I learned very quickly when I was working in Google Earth VR was that the display itself will fuzz out at the edges when you're moving quickly. This is to avoid motion sickness, because most of the motion sickness detectors happens at the edges of your point of view. But this is an interesting way of looking at the world, but it's also a way to be able to display and explore very large data sets, whether that's the data set of the world or any other large, big data set. All right. Finally, what I want to show you is another app that I love. It's not very popular, but it was very useful, called Soundstage. Soundstage is an electronic musician studio. So what it does is it creates a virtual reality studio with virtual instruments, and it allows you to then patch these virtual instruments together. In other words, feed the output of one into the input of another to create circuits of instruments, just the same way that an electronic musician would do it with physical instruments and physical patch cords inside of a studio. Then you can use the controllers as instruments, as whatever you want to do with them to be able to fire things or play things in any particular way. What this is showing you is that VR is a good environment for simulation as well, and you can basically simulate arbitrary things in virtual reality and then give someone the ability to be able to play with those elements of simulation, to be able to rearrange them in any form that they decide is important or useful to them. And so it becomes a playground for simulation in a very significant way. So we have these ideas, okay? So we have Tilt Brush, we have Google Earth VR, we have Soundstage, we have these outstanding examples of how modern virtual reality systems can do things that are very hard to do on a desktop. But in the middle of all of this, something else happened. Augmented reality, which of course goes all the way back to the original system. The Sword of Damocles is an augmented reality system because you could see the real world through it. Augmented reality comes roaring back unexpectedly in 2016 in an app called Pokemon Go. And of course, Pokemon Go became this enormous viral hit. What would happen? You'd look through your smartphone screen and you'd see Pokemon in the distance. You'd capture them. You'd bring them to a Pokemon gym and exercise them or play them against other Pokemon for games. And it became a way of turning the real world, which was used in Pokemon Go, into a playing environment by layering data, the virtual world, inside the real world. So this is this real combination of augmented reality and virtual reality working together and doing it so seamlessly that, again, it's become one of the most popular games of all time. Now, along with that happening, and along with the first generation of VR headsets coming to market, Microsoft introduced in 2015 a device called the Hololens. Now, the Hololens is the first truly self-contained and consumer price, because it costs $4,000 or $5,000, something in that range, augmented reality system. When I say it's an augmented reality system, I mean that it's got a full setup up here of all of the compute necessary to map out a space in real time, and then for you to be able to put objects in that space or see objects in that space correctly. So you can look away from them and look back again, and they are exactly where they were supposed to be because the headset has completely mapped out the space they're in. And it's using not displays that are faced in front of the eyes, but in fact what it's using is glass, and then the images are projected into the glass. So what you're doing is you're seeing from your eye through the image out to the world. So you're seeing the real world while you're seeing the synthetic images composited into the real world by the way those displays are working. In 2015, Microsoft did this. They announced it. There was no idea that it was coming. People didn't even quite know that this was possible. It was an enormous technical achievement, and Microsoft has again came up with the second edition, which is the HoloLens 2 back in 2019. Now, the way it works and the way all augmented reality systems work by definition is they have to map the spaces that they're in order to be able to augment those spaces with virtual items. And so this is done through a technique called simultaneous mapping and localization, or SLAM. And it's scanning the space, capturing it, understanding it, recognizing it, creating a fingerprint for it. Then you can go over to another space, and when you come back to that space, the device and the systems that it's attached to can recognize that space and then repopulate it with all of the virtual items that were in that space the last time you were there. Now, couple of different use cases for augmented reality systems like the HoloLens. Here's the military use case, and again, we have to go all the way back to that example with the F-86A. The battlefield is an information-rich territory, and being able to integrate the resources that are available virtually with the resources that are available for real in the battlefield in a way that's comprehensible to a soldier operating on that battlefield is a very good skill. It's part of command, control, and communication offers on the battlefield in order to make soldiers more effective. And so there's been a long-term project Microsoft's been doing with the military, which they've been trying to unload now, because they basically got as far as they could. Now it's with the defense contractor to take it the rest of the way. This is probably going to become standard equipment for soldiers. But of course, there's another great example, which is being able to use it on the factory floor. So this is not a new idea. Boeing was actually using it back in the 1990s when they were building the 777 aircraft, which has over 1 million components. And for people who are building this device in real time on the show floor, what they actually needed to do was to actually have integrated information about the parts they were working on and how those parts came together. So Boeing actually prototyped and built an augmented reality system that would allow their shop floor workers to do this. But of course, the HoloLens now basically provides that same capability to pretty much anyone in any shop anywhere for just a few $1,000s. And so we now see how these systems can be used to augment our capacity in real time while we're working on a problem. Now, all of this is starting to intersect with a new technology that started to emerge sort of 2016, 2017, called videogrammetry. So videogrammetry is a way of being able to photograph or really film a scene from multiple directions simultaneously. As you can see in this photo, that's using a rig of around 40 cameras. That's pretty standard. These are 40 high-definition cameras, all trained centrally on a scene. That data is then being brought into a massive array of computers and being calculated in real time to be able to produce not just a static image or two-dimensional image, but a full three-dimensional three-dimensional and really four-dimensional volumetric model of what is in the capture field, and it's being able to do that so that it can then be played back inside of an augmented reality or a virtual reality system. And the thing about videogrammetry is because it's 3 and 4D, it has a quality of verisimilitude which you don't get with static images or with 2D images. It feels real. If someone's captured that way and then they're being played back in front of you, you do get the sense that that person is actually in the space with you because they're filling the space and moving in that space exactly as you would. Now, that became the basis for a project again out of Google called Project Starline. And Project Starline is a way to be able to use augmented reality and videogrammetry as a communications medium. So basically having good scanning cameras basically mounted on top of a television, but it's a television that's also capable of showing you things in 3 dimensions. So it's 3D TV of a sort, depth perception in television. And what it's doing then is it's presenting both sides of the link in 3 dimensions in real time. It takes a lot of computer power to be able to do this, but Google's been working on this for a number of years. They've actually come out with a second edition of it. It costs, I think, something like $20,000, and it requires a relatively high bandwidth link between the connections to get this going. But you can start to see now, particularly now that we have new devices like iPhones that can do spatial capture of information, you can start to see now where we think video communication is going to be going over the next 5 or 10 years. It's going to be going in a direction that looks an awful lot like Project Starline, which is more or less an experiment. I don't know if Google will ever make a product out of it, but what it represents is a direction toward a new class of human-to-human communication in augmented reality. All right, finally we come to the Apple Vision Pro. So the Apple Vision Pro was released by Apple in 2024. It's pretty much the top of the line for VR headsets. It's about $5,000 Australian. It's completely immersive. You put it on and you're in another world. Now, Apple has done a lot of work on the usability and the user interface of these devices so that in terms of its fundamental usability, it's probably better than any other device of similar caliber. So that's really, really good. They've actually thought about that very carefully. But it's fully immersive. So even though it bills itself as a kind of augmented reality device, it's using what we call pass-through augmented reality, which means that the image is coming in through cameras and then being presented on displays in front of you. Now, the quality of that pass-through is very good. There's no question about that. It looks almost indistinguishable from an unobstructed view of the world. However, it is being processed and there's some lag and all of the other effects that you get associated with that. And I've noticed in my own self, I will tend to get much more exhausted in an Apple system than I will if I'm using a HoloLens, because on the HoloLens, I'm just looking out at the world. Here, I'm actually looking through a whole bunch of layers of processing. So it's pretty much the state of the art. And of course, one of the big advantages is it can project spatialized video, which you can shoot with the latest 2 generations of iPhones. You can shoot spatialized video. So this is videogrammic video, and you can upload it to the device, and it puts you in the scene basically as if you're there. And again, this is Apple's way of being able to point to how communication will be going, how we'll be sending video back and forth to one another, how we'll be sending messages back and forth to one another in future, using videogrammetry, using that 4-dimensional capture. And so we do come back to this basic question, is the future going to be pass-through or is it going to be glass-through? And it's not really clear, right? We know that Apple wants you to have a pass-through future where it's going through the lenses. But I have a feeling that in fact it's going to be something that's more glass-through. But glass-through devices don't work everywhere. They don't work in bright light. Pass-through devices do. So it's probably going to be a case of horses for courses. Some devices will be used in some situations for some things. Some devices will be used in other situations for other things. This technology is still very much in process. Even though we've been at this for 70 years, it still feels very much like we're just getting started. And that makes your work important because the work that you're doing actually is helping to define the future direction of the field. Once again, I'm Mark Pesce. Thank you for watching. If you have any questions, here's how you can email me. Have a good day.